Hi everyone, and welcome to the second of two videos going through some past exam questions on the topic of qualitative analysis. This question here is saying a student is researching chlorine, discovered that seawater contains chloride ions. They added silver nitrate to a sample of seawater. What would happen? So we saw this in the previous video. Silver nitrate is what you use to test for halide ions. If we've got chloride ions, we're going to end up with a white precipitate. Remember, the bromide ions would give you a cream precipitate, and iodide ions would give you a yellow precipitate. Write an ionic equation. Again, we saw this in the previous video. So including the state symbols, they always want you to put state symbols on these because it shows that you're making a precipitate. So what's happening is it's going to be the aqueous silver ions from the silver nitrate are going to react with the aqueous chloride ions, and it's going to make our silver chloride solid precipitate. After carrying out the test, the student added dilute aqueous ammonia to the mixture. What would they see? So this is adding the ammonia is the precipitate going to dissolve? So what's going to happen here is the silver chloride precipitate will dissolve in dilute ammonia. So you see the precipitate would dissolve. Remember that the silver bromide precipitate won't dissolve in aqueous ammonia. It will only dissolve in concentrated ammonia. And the silver iodide precipitate won't even dissolve in concentrated ammonia. It won't dissolve at all. Okay, this part here says, in an experiment, a student makes a solution of strontium chloride by adding excess hydrochloric acid to strontium carbonate. Describe what they would observe and write the equation. Okay, so what we'd see if we're adding an acid to a carbonate, we'd see the solid strontium carbonate would disappear into solution, and you'd get some fizzing because we'd get a gas being produced. Okay, we're going to get an acid and a carbonate. It's going to make a salt and water and carbon dioxide, isn't it? So then in the equation, we're adding hydrochloric acid, which is HCl. Strontium carbonate, strontium, hopefully we know this, but if we have a look, strontium is our group 2 element. Okay, so strontium carbonate is just going to be SrCO3. Remember, the carbonate ion has that 2- charge, so it balances the 2+ charge from the strontium. We're going to make strontium chloride, they've told us that, and we're going to make water, and we're going to make carbon dioxide. And then we just need to balance it by putting a 2 here, because we've got 2 chlorines. Right, and then this is going back to some bonding from earlier on. Draw a dot cross diagram to show the bonding of strontium chloride. Well, it's going to be ionic bonding, isn't it? We've got a metal and a non-metal. So we're going to have the strontium ion is going to have lost the 2 electrons from its outer shell. So I'm going to draw it with none in its outer shell. It's going to be a 2+. And then the chloride ion is going to have 7 in its outer shell, plus 1 that it's gained from the strontium. And we're going to have 2 of those ions, aren't we? So that's what our strontium chloride should look like. Okay, moving on. This question here is saying, a student is testing chlorine gas with damp blue litmus paper. The litmus paper first turns a red colour and is then bleached. Okay, so that is the characteristic, that's the identification for chlorine. A reaction takes place between chlorine and water in the damp litmus paper. Write the equation for the reaction between chlorine and water. So this is going back to our knowledge of group 7 of the halogens. So if chlorine reacts with water, remember this is a disproportionation reaction. You end up making your HCl, where your chlorine's in oxidation state, -1, and HClO, where chlorine is in oxidation state, +1. Is that balanced? Yes, it is. Explain why the litmus paper turns a red colour. So why is it red? Well, red indicates acid, doesn't it? It's because both of these products are acids. Okay. Okay, the products of the reaction and it is actually both of them are acidic. Okay, bleach is made by reacting chlorine with cold dilute aqueous sodium hydroxide. It's just a form of the ion responsible for bleaching. So this actually goes back to this question as well, because if you notice here, the litmus paper turns red and is then bleached. So whatever ion has come from the reaction with sodium hydroxide, it must also be an ion that was made in this reaction, because we ended up with bleaching in this reaction. So what ion is it going to be? The one that causes the bleaching is the ClO minus from here. Okay, that's your ion that actually gives you the bleaching. Right, last question here at the bottom. Calcium chloride can be made by different reactions. A student prepared some calcium chloride by carrying out this experiment. Added an excess of a solid calcium compound, which they're not telling us what it is. So some sort of calcium compound, they added it to acid, it fizzed as a solid reacted. They filtered it and ended up with calcium chloride. And then when they evaporated it, they ended up with some crystals. Okay. Describe a test which the student could have carried out to prove that the filtrate contains chloride ions. Right, so this is the same question they're asking us again. If we're testing for chloride ions, we're going to add silver nitrate solution. And if the filtrate contains chloride ions, then a white precipitate will be seen. A friend of the student suggested that solid X was calcium oxide. State one reason why the student's friend was incorrect and suggest a possible identity. Okay, so it wasn't calcium oxide. So they added an excess of, well, if it was, so let's say if they added calcium oxide to dilute hydrochloric acid, it fizzed as a solid. Right, so this is the problem. If we had calcium oxide, there's no reason for it to fizz. Calcium oxide and hydrochloric acid is going to make calcium chloride and water. There's no fizzing there. So the reason was if calcium oxide was added to HCl, there would be no fizzing. As no gas is produced. So what could it have been? Well, things that would cause a fizz, maybe calcium carbonate. Okay, because then it's going to fizz because it's going to make carbon dioxide gas. It did say a solid calcium compound. So you could say if you just had calcium and acid would make hydrogen gas, but that's not a calcium compound, is it? So it's going to have to be calcium carbonate.